To the left of the 12-volt battery is a Part 15 AM transmitter tuned to 1680 kilohertz. The transmitter is in development and not in its final form. With a 5-foot wire antenna tuned to resonance, the oscilloscope is monitoring the 1680 kilohertz waveform. For now, the tuning is adjusted by sliding a ferrite core in and out of a coil taped to the counter in front of the transmitter. The coil is a do-it-yourself loopstick made of 16 feet of number 36 magnet wire scramble wound on a syringe. It's a dirt cheap version that performs better than the legendary Miller 6300 loopstick, probably because the wire is so much thicker. In front of the scope is an antenna tuning monitor that offers both visual and audible indication of resonance. On that board, visible under the scope's black vertical position knob, is a red LED that starts to light up as the antenna approaches resonance. It's brightest at resonance. However, an LED is not perfect for this. The human eye has a harder time distinguishing different brightness levels when an object is already bright, but the human ear is quite sensitive to minute differences in pitch, so an audible indicator is included. As you'll see and hear, the audible monitor provides greater tuning sensitivity. With tiny changes in position of the ferrite core, we can hear very distinct differences in tone, while the LED doesn't seem to change at all. The circuit is very simple, consisting of a transistor wired as an emitter follower that amplifies the RF and feeds it into the voltage control pin of a 555 timer wired as a voltage controlled oscillator. The 555 was not primarily designed to be a voltage controlled oscillator, and one quirk is that the pitch decreases as the control voltage increases. Although this is opposite the function of a typical voltage controlled oscillator, it makes no difference in the functionality of this circuit. There are dozens of ways to modify this circuit to turn it around, but as you will see, the goal of perfect antenna tuning is met with this simple circuit as it is. Now, let's see and hear it in action. Note how the LED and the tone track the amplitude of the waveform. I'll start with the tuning out of resonance. The antenna is out of resonance. The LED is not lit. The tone is at its highest point. Now, as I start pushing the rod in, and you can see the amplitude increasing, the LED starts lighting up, and it gets brighter and brighter and brighter with a corresponding decrease in pitch. Now, the LED is at its brightest point, and yet there's still room to go. You can hear the pitch going down. This is the lowest point of the pitch, so this is at full resonance. And as I keep pushing the rod back in, the LED stays the same brightness while the amplitude decreases, but the pitch goes back up. And now I'm going to push it even further to take it further out of the resonance, and the LED goes out. So the LED is out, it's out of resonance. Going back into resonance, the LED starts lighting up again. No change in pitch yet. Now the pitch starts changing. Peak amplitude, lowest pitch, higher pitch, losing amplitude, LED still bright. Now the LED starts getting dim.